Hey guys! All right, so next lesson is calculating the area of a circle. And I'm going to give you the formula in a bit, but in order for the formula to make sense, there's just a couple of things that we do need to review. So obviously, this is a circle. And just to review, this shape on the right is a parallelogram. Now, if you remember from grade 7, the formula for a parallelogram is A equals base times height, right? So the base of the parallelogram is this here, and the height is always the dotted line that runs from the bottom to the top, or depending on where the shape is situated or how it's flipped, but it always runs at a 90-degree angle with the base. So that's the height. This is the base. And it always runs 90-degree angles, that perfect L, or it also runs perpendicular, right? Like that to the base. So what I've done down below is you see the circle here down below. And if you divided the circle into 4 equal parts, for example, cut those parts out and then arrange them inside the shape of a parallelogram, you would see that all of that shape inside the circle, or that mass inside the circle, fits equally into the shape of a parallelogram. So if you notice with the parallelogram, again, if we were trying to figure out the formula for this, or for the area of this particular parallelogram down here, we would find the height, right? Like the dotted line or the line there, and then that would be the base, right? So think of how that is similar to a circle, or how that relates to the circle, I should say. So basically the height is pretty much the radius of the circle. I'm just going to find a darker color here. So if you look at this distance here, it's pretty much this distance here. So the height of a parallelogram is equal to the radius of a circle. Okay? And then if you look at the base of this parallelogram, like if you were to take all these pieces and put them back together again, it would form the whole, like all of this here, all the blue edges would actually become the circumference of the circle. So if you put all the edges together, that's the full circumference. But if we're just looking at the base, it's just half of the circumference of the circle. So the base of the parallelogram is equal to half of circumference of the circle. Okay, so let's kind of go over that again. I know it can be a little bit tricky, but the height of a parallelogram is equal to the radius of a circle. And the base of a parallelogram is equal to half of the circumference. Because again, if we were to put all of these pieces together, it would form the whole circumference. But we're just looking at the base. We're just looking at half. So it's basically just half of that circumference. Okay? Okay, so a couple things to recap. Area of a parallelogram is base times height. Area of a parallelogram is also equal to half of the circumference of a circle times the radius, right? Because if we look back at the other page, if area of a parallelogram is base times height, well, base is here, height is here, right? So this base is half of the circumference, and the height is equal to the radius. So that's why area of a parallelogram is also half of the circumference times radius. Which means that if the area of a parallelogram, if a parallelogram is very equal to a circle, it means that the area of a parallelogram is going to be very similar to area of a circle. So that means that area of a circle is half of circumference times radius. So if area of a circle is half of circumference times the radius, that means that if we put it into a proper formula without words, that would mean area equals half of the circumference, right? Times the radius. We would do it like that. Or half times the formula for circumference. If you remember, one of the formulas, it's either pi times d, or because we're dealing with radius, it's pi times r times 2, right? So we would go pi r2 times the radius, right? Because all we did just now is we took the circumference, we took c, and just put it into the formula here, because we know that circumference is actually pi r2 or pi d, but in this case we're dealing with the radius, okay? So another way to say that, or another way to kind of break down this formula would be, so now we kind of have to solve this, right? Now, half times 2 is actually 1. So to break this down further, it would be 1 times pi times r, right? Because all I did was solve for this. I did half times 2, and that equals 1, okay? So now the next step, 1 times anything is going to be that same number, right? 1 times 50 is going to be 50. So 1 times pi, 1 times 3.14 is going to be 3.14. So there's really no point in even putting the 1 there. So now to break this formula down further, we have pi times r times r. Well, another way to state r times r would be r squared, right? If you remember from our first unit, 2 times 2 is actually 2 to the power of 2. 5 times 5 is actually 5 to the power of 2. So r times r is actually r to the power of 2, which means that our actual simplified formula for area of a circle is pi times radius squared. So I know that's a lot to take in, but please review that video again just to make sure you understand how we arrive at the formula for area of a circle. So again, area equals pi times radius squared. So hopefully breaking that down helps you differentiate or tell the difference between the area of a circle versus circumference of a circle. So, when you're asked to calculate both of them on a test or another kind of assessment, at least you'll hopefully remember the formula because you know how to arrive at that formula. So now let's kind of put that into practice. So just say you have a circle and you are given the radius. The radius is, let's say, 6 meters. Okay, now calculate the area of the circle. So again, you'd go area equals pi r squared. Area equals 3.14 times the radius, which is 6 squared. So then I would do area equals 3.14 times 36, because 6 times 6 is 36. And then 3.14 times 36 is actually 113.04. And again, it's always in square meters or square centimeters. So don't forget to square your final answer. We'll do one more example. There's a circle. Let's say the radius is 10 centimeters. Let's apply the formula. A equals pi r squared. A equals 3.14 times 10 to the power of 2, or 10 squared. A equals 3.14. 10 times 10 is 100. A equals 3.14 times 10, or sorry, 100 should be there, is 31 times 4 centimeters squared. Just one last thing to note, if you're given a question where they give you the diameter and they ask you to calculate the area, so if you're given the diameter of 15, for example, 15 meters, don't forget that when you're applying the formula, pi r squared, r is radius. So if they give you the diameter, you're going to have to divide the diameter in 2 to get the radius, because we know that the radius is half of the diameter. So you'd go 15 divided by 2 is 7.5, and then you'd put that into your formula. Okay? And this is your assessment question. Determine the area of each object. And again, they give you the formula. So they give you one radius and one diameter. Don't forget what to do with diameter. And please do that on Google Classroom. And I will see you guys tomorrow. Have a good night.